Hello, everyone. This is an introduction to our paper, Entity-Aware Dual Co-Attention Network for Fake News Detection. I'm Xinghan Yang from National Taiwan University. This is a joint work with AIRC, AIST, and Academia Sinica. First, we all know that deep learning are successful in many fields. However, these models are mostly black boxes, which means that the decision process or prediction process are usually unknown. Second, the widespread of fake news have negative impact on societies. However, most of the fake news detection models are usually black boxes as well. To address these issues, we propose dual co-attention network, which is called dual CAN. Dual CAN receives two kinds of input resources, news contents and user comments. First, we use a tool called TakeMe to generate entity descriptions. TakeMe capture the entity in the news contents and crawl the description from Wikipedia. So after using tool TakeMe, we have the third kind of resources, which is entity description. To address these resources, we use three kinds of encoder to encode them respectively. The first encoder is entity-aware entity description encoder, which is a word encoder which I will introduce later. The output of this encoder will be a series of vector D. For user comments, we use user comment encoder, which is using word encoder as well. The output of this encoder will be a series of vector C. For news content, we use news content encoder. First, we use word encoder as well, but in order to capture the relation between sentences, we use sentence encoder above the word encoder. The output of the news content encoder will be a series of vector S. For word encoder, we use bidirectional gating recurrent unit to encode a series of words into a vector VI. Second, we perform attention mechanisms to calculate the attention weights of the word label. And second, we use this attention weight to multiply the original vector VI to generate new vector V plum. For news contents, we use sentence encoder. Sentence encoder used by GRU to encode a series of sentences to generate a representation of this news contents S. The second part of our model is dual co-attention layer. In this slide, I introduced the co-attention layer between the entity description and news contents. For user comments and news contents, we use the same calculations as well. First, we calculate the relation between the entity description and the news contents to calculate the matrix F. Second, we calculate the co-attention matrix between the entity description and the news content. Finally, we calculate the attention based on the co-attention matrix and to generate the attention weights ASI and AD, and use these attention weights to modify the original encode of the entity description and news content. The final part of our model is prediction layer. We concatenate the co-attention from the news content and entity description and the co-attention from the news content and user comments. We feed the results into a two layers linear neural network and make the final prediction. To evaluate our models, we do experiments on two benchmark datasets. The first dataset is Gossip Hub, which collects the news contents and user comments from fact-checking website. CLAID is a benchmark dataset for COVID-19 misinformation. The details are shown in this table. We compare our method with three kinds of models. The first model is by GRU, which I have introduced this before. The second kind of models are BERT and its related method like Robota and LinkBERT. The third kind of models are Defend, which is also a fake news detection models which use co-attention network. Notice that their pre-processing methods are different than ours. Compared with this method, our duals can reach the best performance in Gossip Hub and CLAID. In addition to experience on accuracy. We also do some evaluation study to know that whether the role of the user comments and entity description. In Gossip Cup, with user comments and entity description, our model reached the best results. For COAID, only using news contents and user comments already have a very nice performance. We believe it's because for COAID, the news content are usually very short, which is hard for TechMe to capture the entity description. To interpret our models, we analyze the attention weights in the word and sentence level, which is from the word encoder and the dual collision layer. We use heat map to visualize the attention weights of the sentence level. If a sentence have a higher attention weight, it will have a darker color. For entity description, in two data sets, the sentence in the first few sentences usually have a higher attention weight. We believe it's because for entity description, the first few sentences are usually summarized or giving some introduction to the entity, which is useful for fake news detection. For user comments, the later parts of the comments usually have a higher attention weight. We believe it's because after discussions, users usually have some conclusion or some sum up of the article, which is useful for the fake news detection as well. Also, we do some case studies to understand which kind of news content or entity description or user comments are useful for fake news detection. For news content that contains keywords, usually have a higher attention weight. For the entity that's description that are introduced some keywords, usually have a higher attention weights as well. That's it. Thanks for your listening. For more detail, please see our paper and code. Feel free to email me if you have any question.